time travel. The very concept sparks our imagination. We dream of venturing into the past or glimpsing the future. Science fiction tantalizes us with possibilities. But what does science have to say? Can a car speeding at 300 kilometers per hour actually bend time? The answer lies in the mind of a genius. Albert Einstein, with his theory of special relativity, unveiled a universe where time is not absolute. It's relative, a dance between observers and their motion. Time, it turns out, can be stretched and squeezed. This mind-bending concept is called time dilation. It's a cornerstone of modern physics. It tells us that time passes differently for objects moving at different speeds. The faster you go, the slower your clock ticks compared to someone standing still. So, can our speeding car become a time machine? Let's dive into the physics and find out. We'll explore the equations and uncover the truth about time travel at 300 kilometers per hour. Einstein's theory of special relativity revolutionized our understanding of space and time. He proposed two postulates that shook the foundations of classical physics. The first stated that the laws of physics are the same for all observers in uniform motion. The second postulate declared the speed of light in a vacuum to be constant for all observers. This seemingly simple statement had profound implications. It led directly to the concept of time dilation. Time dilation, a consequence of special relativity, states that time passes slower for a moving object relative to a stationary observer. The faster the object moves, the slower time passes for it. This isn't just a theoretical concept, it's a measurable phenomenon. The time dilation formula quantifies this effect. It allows us to calculate the difference in time experienced by a moving object and a stationary observer. This formula is the key to understanding how fast a car needs to travel to experience a noticeable shift in time. The time dilation formula T equals T divided by the square root of 1 minus V squared over C squared might seem daunting, but let's break it down. T represents the time experienced by the moving object, while T is the time for a stationary observer. V is the velocity of the moving object, and C is the speed of light. Let's plug in the numbers for our car traveling at 300 kilometers per hour. Converting this to meters per second, we get approximately 83.3 meters per second. The speed of light is a staggering 299,792,458 meters per second. Clearly, our car's velocity is tiny compared to the speed of light. Calculating the time dilation, we find the difference is incredibly small. Over a year, the car's clock would be behind a stationary clock by a mere fraction of a second. We're talking about a difference measured in nanoseconds, far too small to perceive. So, while our car at 300 kilometers per hour technically experiences time dilation, it's practically insignificant. To experience noticeable time travel, we need to crank up the speed considerably. Section 4. The need for speed time dilation at higher velocities. To witness substantial time dilation, we need to approach the speed of light. At speeds closer to CE, the time dilation effect becomes increasingly pronounced. Imagine a spaceship traveling at 90% the speed of light. Time would slow down significantly for the astronauts on board. At 99% the speed of light, time dilation becomes even more dramatic. A year for the astronauts might be equivalent to decades on Earth. This is the realm of true time travel, where significant jumps into the future become theoretically possible. However, reaching these speeds presents an enormous challenge. As an object's velocity approaches the speed of light, its mass increases infinitely. This means it would require an infinite amount of energy to accelerate to CR, making it physically impossible. The speed of light acts as a cosmic speed limit, a barrier we cannot cross. While we can approach it, reaching it remains a distant dream. Section 5. Conclusion: the limits of time travel. So, can a car traveling at 300 kilometers per hour time travel? Technically, yes, but the effect is so minuscule as to be imperceptible. Time dilation is a real phenomenon, but it becomes significant only at speeds approaching the speed of light. While our car might not be a time machine in any practical sense, the concept of time dilation opens a window into the strange and wonderful world of relativity. It reminds us that time is not absolute, but a fluid dimension intertwined with space. The speed of light remains an insurmountable barrier, preventing us from reaching the extreme time dilation effects depicted in science fiction. But the journey of exploring these concepts expands our understanding of the universe and our place within it. While we may not be able to zip through time in our cars just yet, the quest to understand the nature of time continues to drive scientific inquiry, pushing the boundaries of human knowledge.